Good morning everyone, welcome back to Question a Day. Today is July the 10th and we'll be answering yesterday's question on transformations. But before we begin, today is Asala Puja or Dharma Day, which is a Buddhist festival. The question we have is we've got this cubic, y is equal to x cubed minus 4x squared, take 8x plus 9. And we're moving it 2 units to the right and 3 units down. We want to know what the new equation will be. So this is a bit of a transformations thing going on. And what we're going to want to do is encode these transformations into our graph. So first off, we're moving 2 units to the right. So we're going to remember from our transformations that if we do f of x subtract a, so this is inside the bracket, we're doing it to the x, that is a translation along the vector a0. So translation to the right of a. Similarly, if we do f of x subtract a, that's a translation along the vector 0, a. So if we subtract a, that's going to move us downwards. So it should be 0 minus a. So subtracting a is going to move us downwards. So we can encode this. We want a transformation where we move 2 units to the right. So this letter should be here, should be 2. And this one, we want to move 3 units down. So we're going to take our curve, y, and we're going to replace all our x's with x subtract 2. So that will move as our 2 units. So we get x take 2 squared, x take 2 cubed minus 4x take 2 squared, take 8 x take 2 plus 9. And then to this whole thing, so we'll just pop this in some square brackets for the moment. So this entire equation, we're going to subtract 3 to move it 3 units downwards. So now all we have left to do is expand all of these. So for our first bracket, it might be useful to use our binomial theorem if you want a bit of practice with that to expand this cubic. But we could just remember that we're going to get an x cubed, first of all, from doing that. We're going to get 3 times x squared times minus 2, which is going to be minus 6x squared. Going to get 3 times minus 2 times minus 2, which becomes plus 12x. And then that minus 2 cubed is going to become minus 8. So that's this first part expanded. And we'll just highlight that where that has come from. So that has generated that section. Now we're going to subtract 4, this slightly easier expansion. 4 times x minus 2 squared, which as we know is x squared, take 4x plus 4. And then minus 8 x take 2 plus 9, and take away 3 from the entire thing. So now we've got all that written out, we can expand everything, everything that we've not already expanded, collect all the like terms, and that will be our solution. So we get, once again, x cubed minus 6x squared plus 12x, take 8. We get minus 4x squared, take plus, so we don't want to forget that minus, plus 16x, take 16, minus 8x plus 16 plus 6 there. So that's that plus 9, take 3. Now we can go through, we can spot a little bit of cancellation. So these 16s are going to cancel out. And we're just going to start collecting some like terms. So we've got our x cubeds. We've got minus 6x squared minus 4x squared, which is going to become minus 10x squared. we're going to get plus 12x, and that's 16x, minus 8x is going to become plus 20x, and then we have minus 8 plus 6 is minus 2. And that whole thing is going to be equal to our y. This is our new curve. So here is the graph that we were talking about. This green curve here is our original function, y equals x cubed minus 4x squared, take 8x plus 9. And what I've done here, I've plotted our other graph, so our x cubed minus 10x squared plus 20x minus 2. And so I've plotted these both on GeoGebra. I've taken a vector, so this vector drawn here, I know it looks a bit weird, the scaling's a bit funky on here, but that is the vector 2 minus 3, so that's the direction that we wanted to go with our transformation. So I've plotted that vector on, that's one poking out from 15 there. And then I've attached that to the graph. And what I can do is I can kind of shift this around, and hopefully you can see that end. So the start of my vector is obviously it's on the green curve, and the end of it is always attached to the same point as the equivalent place on the blue curve. So that is that transformation. There you go. So hopefully that's going to make it a little bit more visual for why this kind of works. Is what we've done. We've got our new equation, and that's shifted everything across by 2 and down by 1. Okay, hopefully that's helpful. Anyway, that's all for today, and I'll see you tomorrow.